So we're going to walk through those last two examples that we did not get a chance to complete in class today from the notes. So in number 10, the first thing we're going to notice is that the second part of this problem is a fraction. So a good idea might be to use some identities to rewrite tangent theta as a fraction. And if we use our quotient identities, we know that we can rewrite this as sine theta divided by cosine theta. And then we'll leave the second fraction alone. Now again, because of the plus sign, we can't do any cross-reducing. So what we need to do now is combine these two fractions together into a single fraction. And again, when we want to combine two fractions into a single fraction, we want to find a common denominator. And our common denominator in this case is just going to be the product of those two pieces. So we're going to take that cosine theta and multiply it by 1 plus sine theta. And that's going to be my common denominator. So as I try to put these two fractions together with this common denominator, I need to multiply each fraction by the missing factor. So if we look at that first fraction, it already has the cosine theta from our common denominator, but it's missing that 1 plus sine theta factor. So I'm going to take that numerator sine theta, and I'm going to multiply it by that missing 1 plus sine theta. Then I'm going to put my plus sign from between the two fractions. And then my second fraction here has the cosine theta up top. And in the denominator, it has 1 plus sine theta, so it's missing the cosine theta. So I'm going to multiply both of these by cosine theta so that I create that common denominator and I combine these two. What we want to do next is simplify that numerator. So to get rid of these parentheses, we'll use our distributive property. So we're going to get sine theta plus sine squared theta when we multiply those two terms by sine. And then here I have cosine theta times cosine theta, so I can combine them into just cosine squared theta. When you multiply something by itself, it gets squared. So I'm going to clean up the numerator, but I'm not going to do anything with my denominator right now because my ultimate goal is going to try to cancel some things out. So if I leave this as a product, I have a good chance of being able to reduce out some items. So I'm going to leave that denominator alone. And what I want to do now is kind of look up at that numerator and figure out what can I clean up in there? What can I simplify? And as I'm looking there, I can see a couple trig functions that are being squared. And we have sine squared theta plus cosine squared theta. And if, again, we think of our Pythagorean identities, we know that that's equal to 1. So I can now condense those two terms together into just 1. So my numerator will become sine theta plus, replacing all of that with 1. And then my denominator will stay in that factored form. And once I have this cleaned up, what I notice now is that I have this entire group of 1 plus sine theta in the numerator. And that matches this group down here. So even though they're written reverse, we know that addition's commutative. 2 plus 1 is the same as 1 plus 2. So in this problem here, I can actually cancel out this entire quantity of sine theta plus 1 with that quantity of 1 plus sine theta down in my denominator. And if I cancel these two out, I'm going to be left with a 1 in my numerator, and down in my denominator, just that cosine theta. And if I use my reciprocal identities, I can simplify this one step further and make that secant theta. So notice in this problem, we use that strategy of combining two fractions together. And then once we combine those fractions, we cleaned up the numerator by distributing. And then we looked for those Pythagorean identities to try to further simplify that numerator. In our final example, what we're going to do is we already have a single fraction. And as we look through the fraction here, we can see that the numerator has these two terms that are both using sine cubed x. And again, the nice thing about trig functions is that when you see a repeated trig function like this, we can factor it out as a GCF. So up in the numerator, I'm going to take out that sine cubed x as a GCF. And then in parentheses, I write what gets left behind after I factor out that common factor. So if I divide this first term by sine cubed x, I'm going to be left with cosecant squared x. then my minus sign. And if I take sine cubed and I factor out sine cubed, I'm going to be left with 1. And that's all going to go over that cosine cubed x. Now, what I want you to notice here is that I've basically now created a product in that numerator. And when you have a product in your numerator, you can kind of shift around that denominator and match it up with either piece. So what I'm going to do is I'm going to match these guys up here. And using my quotient identities, I know that sine cubed x over cosine cubed x is going to become tan cubed x. And then in the second part of this problem here, we have that cosecant squared x minus 1. And again, whenever I see a trig function squared with a 1, I look to my Pythagorean identities. And we rearranged all of our identities, and we found out that cosecant squared x minus 1 is the same as cotan squared x. So I'm going to replace that part of the problem with cotan squared x. And now that I have these two pieces simplified, I'm going to use some more identities to further combine these two pieces together. Since I'm using a tangent and a cotan, I'm going to rewrite the cotangent as a reciprocal identity. And we know that cotan is the reciprocal of tangent. So I'm going to put this tan cubed x over 1. So I have a fraction. And then I'm going to multiply it by 1 over tan squared x using my reciprocal identity. Then if I combine these together, I'll get tan cubed x divided by tan squared x. And if we use our properties of exponents, we're going to keep our base and subtract the exponents. So 3 minus 2 would give me 1. So this would all simplify nicely down to just tan x. And so now we have a basic set of identities that we used by starting out with a common factor in our numerator. And then we just kind of regrouped the fraction. And as we regrouped them, we used our quotient identity to get that tan cubed x. And then we used our Pythagorean identity to get that cotan squared x. And then we went one step further with our reciprocal identity so that we can further simplify. If you have any other questions about simplifying your trig functions, please reach out to me.